All right, I did have to just make this in two different videos because this notepad just started to not work. So I needed to just save that last one and create a different one. So this says in the class of 40 students, 23 have dark hair, 18 have brown eyes, and 26 have dark hair, brown eyes, or both. So how many students have? So first thing that we will need to do is we'll need to draw our Venn diagram. All right, so we have dark hair and we have brown eyes. So let me just redraw these here a little bit better and clear to see. So we have dark hair and then we have brown eyes. So D, B, and there's our universe. So class of 40 students, 23 have dark hair, 18 have brown hair, and 26 have dark hair, brown eyes, or both. So how many students have? Right, so there's only 26 students that have dark hair, brown eyes, or both. So that means those 26 will only account for everything in these two circles. So although there's 40 students in this class that we have looked at, only 26 are the ones that we're focusing on when we're going to solve for dark hair, brown eyes, or both. So that means 23 people have dark hair. So remember, 26 have dark hair or brown eyes. So of these 26, they have to have one or the other. Well, if 23 of them have dark hair, that means the remaining have to have brown eyes. So there's a total of 26 people and 23 have dark hair. So that means there's 3 that have brown eyes. So this has to go here. So those 3 people must have brown eyes because this 26 has either dark hair, brown eyes, or both, but they have to have one or the other. And since 23 have dark hair, that means the remaining 3 have to have brown eyes. So if 18 have brown eyes and there's 26 that have dark hair, brown eyes, or both, that means the remaining of those 18 people must have dark hair. So 26 total have brown eye, dark hair, or both. 18 we know have brown eyes. That means the remaining 8 must have dark hair. So if 23 people in general have dark hair and 8 of them only have dark hair, then these two sections, section A and section B, have to add up to 23. Well, if we already have 8 here, well, 23 minus 8, that is equal to 15. So that means 15 people have to have both dark hair and brown eyes. And we can check our work because here in circle B, this 15 plus 3, that adds up to 18. And that's how many people in total we said have brown eyes. So we know that we did this math correct. And if there's 40 total students and 26 have brown hair, have dark hair, brown eyes, or both, that means the remaining people have neither. So if there's 40 total students and we accounted for 26, we would subtract that out. That means 14 students don't have dark hair or brown eyes. So how many students have dark hair and brown eyes? That's this intersection part here, so that would be 15. How many students have neither dark hair nor brown eyes? So that's this part out here, because they don't have either of them. So it's 14. And how many students have dark hair but not brown eyes? So this circle is dark hair, and this part is dark hair and brown eyes. So this remaining part is just have dark hair but not brown eyes, so that's 8. Or they only have dark hair. Right? So once we fill in this Venn diagram, it's actually quite easy for us to complete these answers. Right, this says in a class of 40 students, 19 play tennis, 20 play netball, and 8 play neither of these sports. Determine the number of students who... So what we need to do first is fill in this Venn diagram, and everything else will be really easy. So we draw our 2 sets. So this will be people who play tennis. We draw our second set, so that's people who play netball. All right, so they tell us that 8 people don't play either of those. So 8 people need to be on the outside of those 2 sets. So now if we have 40 total people and 8 don't play either, that means these remaining 32 must play tennis or they must play netball. So they have to play one or the other. So we're going to start with netball. So 20 people play netball. So 32 people we know play netball or tennis. So if 20 of them play netball, that means the remaining 12 have to then 100% play tennis because those 32 need to play one or the other. So that 12 needs to go here in this tennis part of our circle that's only tennis. All right? Now 19 play tennis. So that means here, this entire circle, there's 19 people that have to play tennis. So 19 play tennis. We've already said 12 play only tennis. So if we want to find out the number that play both tennis and netball, we can do 19 minus 12. That's equal to 7. So that 7 has to play both tennis and netball. So now we know that 20 people play netball. We've already figured out that 7 play netball and tennis. So if we want to figure out the remaining people that are in this section here, we will do 20 minus 7. So those 13 people must play netball. All right. Another way you could have did this is we know 32 people play tennis or netball, and we know that 19 play tennis. So if we subtract out the 19, that tells us the number of people who have to play netball, and it's the same as the 13. So I was just showing you a different way that you could do it. All right, so how many people play tennis? That's this entire circle. So it would be 12 plus 7, or 19. How many people play at least one sport? So that is one or both. So 12 plus 13 is 25, plus 7 is 32. And we also knew that when we did this part here. How many people play netball but not tennis? So this is netball, and not tennis is this region here. So that will just be the 13. Do not play netball. Well, this is netball is this entire circle. So people who do not play netball is this 12 for the tennis, and these 8 who don't play tennis or netball. So that's a total of 20. And how many people play one and only one of the sports? So they can't play 2 and they can't play neither. So this 13 plays one and only one, and this 12 plays one and only one, and they add together to give us 25. All right, so this one, the directions on your test will say write and set builder notation. All right, that's how it will be on your test. So if we want to write this in set builder notation, we need to start with our set sign, all right? Because remember, this symbol tells us it's a set. And then we pick our variable. So it's a set of all x's, and then such that. And now the next part that gets written here is the solution to what they gave us. So if you notice, the leftmost part of our graph is 0, and the rightmost part of our graph is 5. So I know that my left and all the solutions are in between. Right, all the solutions are in between here. So I know that my left part of the solution will be 0, my right part will be 5, and I know that x is in between because the two answers are combined in one line. If the two answers were drawn like this, where they were not combined into one line, then the x cannot be written in between, right? Because this means that the solution's in between them. So now if you're unsure of where you put your inequality symbols, pick a number that's in between 0 and 5, so 3. And 3 represents a solution, so 3 represents x. So here we would say, because there's x is written on the right of 0. So we're asking ourselves, is 3 greater than 0 or is 3 less than 0? Well, 3 is greater than 0, so that means x has to be greater than 0. Then we pick the same number 3 and we compare it to that 5. So once again, since x is written to the left of 5, 3 must be written to the left of 5. And then we ask ourselves, is 3 less than 5 or is it greater than 5? Well, 3 we know is less than, so we fill it in here. Now, the last thing you have to do is, if you see this 0, it is an open circle, while this 5 is a colored in circle. So when it's an open circle, it's just less than or greater than. But when it's a colored in circle, it gets included. So it's less than or equal to or greater than or equal to. So we need to put this equal sign here. All right, then the last thing that we need to do is we need to define what set this is in. So once we see the number line is drawn, that means it includes every single number on that number line. And the only number set that includes every single number, whether if it's rational, irrational, natural, and integers, it is our real numbers. So we would say that x is an element of our real numbers. All right, I'm going to do one more example where it won't be a real number, where our answer won't necessarily just be real numbers. So if I then draw this here, and let's say -1, 0, 1, and 2, and I put points at -1, 0, and 1. Let's do the 2 as well. All right, so I pick these points. We would start out writing it the exact same way. So the set of all x's such that, then we're going to write our solution. And the same thing. These, although a line's not drawing them, our solution is between this -1 and this 2. So we can still write this -1 and this 2 here. And remember, our x is between them, so x has to go between those two numbers. And we pick one of the solutions or one of the numbers in between 0. And we write it out just like we did. Because x is to the right of -1, so 0 needs to be to the right here. And we ask ourselves, is 0 greater than or less than -1? It's greater than, so that means x is greater than -1. Here we have 2. We picked a point 0. X was written on the left of 2, so we will write 0 and 2. So then we say, is 0 less than or greater than 2? Well, it's less than. And remember, these two circles are colored in, this 2 and this -1, so this needs to be equal to. Right, now, the difference between this problem and this one here is we had the line that connected them. So that was saying every single point in between. This one is saying it's just at our -1, just at our 0, our 1, and our 2. So it's at only at our whole numbers. And the two number sets that have our whole numbers is our natural numbers and our integers. Right? But since this is including a negative number and natural does not include negative, we would have to say that x is an element of our integers. All right, that's it for that one. I think there's one more question, and then that's it for these two videos. All right, I'm sorry, there's two more questions. Now remember, you don't have to watch all these. You can skip through just to the ones that you need help on. So for this one, it says, show these on a Venn diagram. So first thing we want to do is we want to list out what our universe is actually equal to. And on your test, you must use this notation. If you don't, you're going to lose points. So our universe is equal to all the numbers that are less than or equal to 12 that are part of our positive integers. So that's our 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Right? Then we're going to write out our set A. So our set A is equal to multiples of 3. So that's 3, 6, 9, 12. However, it's telling us that these multiples must be less than or equal to 12. So any of these multiples can't be greater than 12. So that's 3, 6, 9, and 12. Any other multiple of 3 is going to be greater than 12. All right, so these are our universe and our set. So you need to write them out first in order for you to then fill in your universe or fill in your Venn diagram. So for here, we're going to fill in, this is our set A, so we'll fill in 3, 6, 9, and 12. So that's 3, 6, 9, and 12. So the rest of these numbers need to then go in our universe, which is everything outside of our set. So 1, 2, 4, 5, 7, 8, 10, and 11. So that is part 1. It's showing our A on a diagram. Now, if we want to list the number list the set A complement, we need to write it out. And remember, A complement is all the numbers that aren't in A but are in our universe. So it's all these numbers out here. So it's 1, 2, 4, 5, 7, 8, 10, and 11. All right. So when it says list, you must write them all out. For C, it says find the number of elements. So the difference between these two is the top one, we need to write all the actual elements out. Here, we just need to say how many. So for C, the number of elements in set A complement is equal to, we just count them up, 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 elements in that A complement. All right, there's one more problem, then we're going to be done going over all the different ones. All right, so this says sketch the number set. So when we're sketching it, we need to draw them on a number line. So here's our number line. Let me just draw this a little bit straighter. So here's our number line. Oh, still not straight, but whatever. So there's our number line. All right, and it's telling us that x is greater than or equal to -2 and less than or equal to 3. So I know that my numbers are going to go from -2, and then we're just going to write them out. So -2, -1, 0, 1, 2, and 3. So I know that my numbers are going to go from -2 to 3. Anything beyond here we don't really care about because x is only between them. Right? And it says that x is integers. So that's a key thing that we need to do here. So x, and this tells us it's equal to -2 and it's equal to the 3. So since it's equal to it, we will put a colored in circle and a colored in circle. Right? This is important. Since it's an integer, that means the only solutions are integers. So this here would represent 2.5. Well, that's not an integer, so that can't be a solution. So we need to put the solutions at all of our integers. So it's all of these numbers in between. All right, so this one we wouldn't draw a line connecting them because that would then tell us that all these numbers in between, these decimals and fractions that are not integers, would be a solution. Right? But if this did not say x is an element of z, but it said x is an element of our real numbers, then we would actually go ahead and draw the line connecting them. Right? So that's where the difference would be. If it was real, we would connect all of our points. And if it was integers, we just draw the dots. Right, now that is all the examples I'm going to go through. So if you have any questions, you can send me on Remind, but that is all.